Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn about planes, or we are going to learn equations related to planes. In the last video, we learned about equations related to lines, and similarly, we are going to go through equations related to planes in this video. Okay, so basically, if you want to visualize a plane, I told you the most difficult thing when it comes to 3D geometries, we cannot make rough pictures, because basically the paper or the screen which you are watching, they are all in 2 dimension. And when you try to create something which is in 3D in a 2-dimensional platform, it won't be perfect. So there are only 2 options. Either you depend on a 3D software, or you have to make models. Yeah, there is one more very powerful thing, that is your imagination. You can visualize all these things in your brain. Okay, so anyway, I'll try to make a plane. Okay, so this is a plane. Do you remember when we learned about lines, I told you the length of a line is infinite. No one can see the starting point of a line, and no one can see the ending point of a line. Anyway, in books we will draw only this much, because we won't be able to draw infinite pictures. But remember, a line is defined like this. It's a collection of infinite number of points, and no one can see the beginning and the end. And if you draw a part of the line, you call it a line segment. Similarly, what I have drawn here is actually a plane segment, but in reality, a plane means it's an infinite picture. And the most interesting part is, mathematicians have defined the equation of plane with the help of lines. I'll show you something very interesting. You can take one notebook or any book, or like a cardboard or something, so that you have a plane in your hand. And now I want you to make a normal to the plane. Normal means you can take a pen and put it perpendicular to the book. So take one book or a cardboard or anything which looks like a plane, and I want you to keep your pen in such a way that it will look normal to the, it means perpendicular to the surface. Now look at this. The equation of a plane is defined with the help of a line, and that line is no one else but our normal. Okay, now the second thing you have to understand is, plane is the only surface in 3 dimension which has all its normals parallel to each other. Look, the blue normal is parallel to the red normal. The red normal is parallel to the orange one. The orange one is parallel to this blue one. The blue one is parallel to this pink normal. So remember, plane is the only surface in which all the normals will be parallel to each other. So what the mathematicians did is, they defined the equation of a plane using the normal direction. I think you already remember, every line has a direction, and we call them direction ratios, direction cosines. Now look at this. Suppose we have a plane. So I'll draw a plane for you. So suppose we have a plane, and remember, since we are drawing this in 2 dimension, I am restricted to draw a plane segment. But in your brain, in your imagination, you should always remember a plane is an infinite structure. Okay, so suppose we have a plane. And let's say the plane has a normal direction or the normal direction ratios ABC. Remember, in vector form, we will imagine the direction to be a vector and we will write AI plus BJ plus CK. But if you learn 3D geometry, we simply write ABC, only the components. Okay, now don't ask me which normal, because all the normals will have the same direction. That is what we learned here. That is a specialty of a plane. Now imagine if you have a paraboloid, or if you have an ellipsoid, some other three-dimensional shape, or even if you have a cylinder, not all the normals will be pointing in the same direction. But remember, plane is the only structure which has all the normals pointing in the same direction. So you can take any normal randomly and let the direction vector be AI plus BJ plus CK, or the direction ratios be ABC, or the direction cosines be LMN. Okay, now what I'm going to do is I want to take one general point in the plane. So I'm going to take the point X, Y, Z. Look at this. You have to understand a plane is made up of infinite number of points, and we are going to find the rule followed by all those points. So for that purpose, I am taking a random point, an arbitrary point X, Y, Z on the plane. And I want one more thing. I want a fixed point. What do I want next? I want a fixed point x1, y1, z1. Now look at this. If I join them, you will see that line segment, can you see the blue to red line segment? It will be on the plane. And since it is on the plane, this red line segment will be perpendicular to the black direction. Or in vectors, we can easily say vector PA or vector AP. You can draw any direction you like as you wish. So basically, vector AP will be perpendicular to the normal. Okay, now what is vector AP, or what is the direction ratio of this line? You know how to find the direction ratios. You have watched lesson 1, lesson 2, you know that. So the direction of AP, or direction of the direction ratios will be x minus x1, y minus y1, z minus z1. If you want it in vector form, it is very easy. X minus x1 into I, y minus y1 into j, z minus z1 into k. Wait a minute. This direction is perpendicular to ABC. What is the condition two lines are perpendicular? Didn't you watch the last video? What is the condition for perpendicularity? Or you can imagine in vector form, two vectors are perpendicular if the dot product is 0. Oh, so the inner product, the dot product will be 0. So basically we end up having the equation A x minus x1 plus B y minus y1 plus C z minus z1 is equal to 0. Okay, so remember, this is the equation of a plane having one fixed point x1, y1, z1 and normal direction ABC. So let me make it very clear. If you did not understand the derivation, I will strongly recommend you just memorize this. So given one particular on the plane x1, y1, z1 and the normal direction ABC, the equation of the plane will be A x minus x1 plus B y minus y1 plus C z minus z1 is equal to 0. Anyway, this is something very important. You can note it down. So basically this is point and normal direction form. So what is this? Point and the normal direction will be given. Now, okay, I'll show you one picture so that you understand this. So take a look at this. I'll remove the grid for you. Okay, so look at this. We have the normal to the plane passing through the point A and the 2 points on the plane, and you can see that they are perpendicular. Okay, so now the second thing that is more important, if you open the bracket, if you open this bracket, you can see that the general equation or the simplified form becomes ax plus by plus cz, and the remaining things will be ax1, that will be a number, by1, that will be a number, cz1, and I'm going to call it d, equal to d. And by the way, book to book it will be slightly different. Some people love to write like plus d equal to 0, and of course some authors write is equal to d. That doesn't make much difference, because when you do a numerical, you will understand that doesn't make any difference. Anyway, I'll have to write ax plus by plus cz is equal to d. So remember, a first degree, a linear equation, a first degree equation in x and y and z will always represent a plane. If you want to like what you call confirm it, I'll draw it for you. So look at this. I'm going to write 2x plus 3y minus 5z is equal to some number randomly. Okay, minus 3, minus 2. Okay, look at the graph. Isn't it a plane? So as I promised, you type any quantity in x, y and z. It should not be x square, y square, z square. It should be first degree. Look, x minus 3y plus 7z is equal to 6. See, another plane. Yeah, by the way, I want you to understand one more thing, something very important, that is the intersection of two planes. Can you just tell me what might be the intersection of two planes? Remember, the intersection of two planes will be a line. The intersection of two planes will be, always remember, the intersection of two planes will be a line. Okay. Now the next point. This is very important. First of all, you have to understand 3 non-collinear points. Non-collinear means points taken in such a way that they don't form a straight line. If you take one point here, you can see that they are collinear points. By the way, the word co stands for same and linear is related to line. So that is why collinear points means points lying on the same line. Anyway, if you take 3 non-collinear points, you will be able to draw a unique plane. If you take 3 non-collinear points, you will be always able to draw a unique plane. Okay, I am drawing the plane segment here. Okay, now let's assume the points are x1, y1, z1, x2, y2, z2, and of course x3, y3, z3. Then the equation of the plane will be x minus x1. It's the determinant. You just expand the determinant. I'm not giving you the proof. x2 minus x1, x3 minus x1. The second column will be y minus y1, y2 minus y1, y3 minus y1. The third column will be z minus z1, z2 minus z1, z3 minus z1 is equal to 0. So if you can by heart, this determinant on expansion will give you the equation of the plane passing through 3 non-collinear points. I'll give you one more option. Okay, look at this. Suppose this is our required plane. And they will give you how many points? 3 non-collinear points. Another technique is, let's say this is A, this is B, this is C. Another technique is you can find the direction vectors AB and AC. So you can find the direction vectors AB and AC. Now look at this. I told you in the beginning itself, the equation of a plane is defined with the help of normal direction. Now look at this. Normal direction means we want a vector which will be perpendicular to both AB and AC. I think in your class 12 or in your grade 12, you have learned that the green vector is, come on, do you remember? The green vector is, okay, I'll ask that question once more. The green vector is perpendicular to both AB and AC. So the green vector will be the cross product. Never forget, cross product is a vector which is perpendicular to two other vectors. So if you want, you can use this technique to find the normal direction. Now, if you have the normal direction ABC or AI plus BJ plus CK and one particular point, we have 3 points here, you can write the equation. Okay, now I'll repeat once more what all things we learned. The first thing we learned is, given a plane and a fixed point x1, y1, z1 and its normal direction, then what will be the equation? A x minus x1 plus b y minus y1 plus c z minus z1 equal to 0. Now, the second equation that we learned is, suppose 3 non-collinear points are given. Suppose 3 non-collinear points are given. Then the equation will be given by determinant x minus x1, x2 minus x1, x3 minus x1. Second column y minus y1, y2 minus y1, y3 minus y1. Third column z minus z1, z2 minus z1, z3 minus z1 equal to 0. So if you're trying to memorize, then this will be the best method. Now if you do not want to memorize, the technique is, you can call the 3 points as ABC, find the direction of AB, that's a direction ratios or direction vector as you wish. Find the direction of AC and remember the fact, the normal direction will be the cross product, because the cross product will be always perpendicular to this AB and AC. So basically we can find the normal direction, and you can use any one of the points A or B or C, and this equation you will get the equation of the plane. Okay, another fact, always remember the simplified version or the general form of an equation of a plane is AX plus BY plus CZ is equal to D or plus D equal to 0. You can study as you wish. Or in other words, a first degree relation between X, Y and Z. Look, X to the power 1, Y to the power 1, Z to the power 1. So remember, the simplified version or the general equation of a plane is AX plus BY plus CZ plus D equal to 0 or equal to D. Okay, now I'll show you another picture. Look at this. Are you able to see, okay, first point. Are you able to see two planes intersect to form a line? By the way, I'm showing a plane segment, not the entire plane. No human being can show the entire plane because it is infinite. Okay, so point number 1, are you able to see the two planes intersect to form a line? So look at this, I took that picture. So are you able to see that the two planes are perpendicular? Or you can take two books and hold them perpendicular, or you can look at the roof of your house and the wall. I'm imagining you're living in a cubicle house, or you can look at the angle between the two walls and the assumption you're living in a cubicle room. Okay, so you can understand this normal, the green normal, and the blue normal will be perpendicular. So remember, when two planes a1x plus b1y plus c1z is equal to d1 and a2x plus b2y plus c2z is equal to d2, if the planes are perpendicular, then you have to understand the normals are perpendicular. And I'll show you another fact. Look, let's imagine we have two parallel planes. Oh, when we have parallel planes, are you able to understand the normals are in the same direction? Think about it. If you consider two planes which are parallel, then you have to understand the normals are in the same direction. Okay, now in the last two videos we learned a lot about lines, the direction of lines. If two lines are parallel or if two vectors are in the same direction, then the coefficients will be proportional. If you did not understand this fact, it is obvious you did not watch the last two videos. So in case you forgot the condition for parallel vectors or same direction vectors or parallel lines, you can watch the last video. So remember, two planes will be parallel, same condition. Now look, this is the advantage when you define plane in terms of a line, because you already know everything about lines. So when you define plane in terms of line, you can use those properties. Now imagine two planes are perpendicular. Okay, so the dot product will be 0, the inner product will be 0. So a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Note these points, these are very important because from the next video we will be working out on problems, and at that point these formulae will be very, very important for you. Okay, now imagine two planes which is making an angle theta. Now I am leaving this to your imagination. So if two planes make angle theta, then I am going to claim that their normals will also make the same angle. So basically the angle between two planes is given by the same formula, dot product divided by modulus into modulus, that is a1 a2 plus b1 b2 plus c1 c2, the whole divided by, what's the formula for modulus? a1 square plus b1 square plus c1 square multiplied by a2 square plus b2 square plus c2 squared. Okay, so that settles the angles. Okay, now one very important point. Look at this. I have seen two types of students. Some students love to deal planes with the help of direction vector. And the advantage for such students is all you need to know is like what you call the formulae from vectors. And at the same time, some students want to learn the planes with the help of direction ratios. Basically the components, that is a1 b1 c1, a2 b2 c2. So if you are using direction ratios, you may not be able to use the amazing result of cross product, because I told you a few minutes back, cross product is a vector which will be perpendicular to two other vectors, and this fact will be used many times when we solve numericals. So for such students, I am going to give you one rule. The rule is called rule of cross multiplication. That is, suppose you have two equations, ax plus by plus cz is equal to 0 and a dash x plus b dash y plus c dash z equal to 0. That is, you have two equations but three unknowns, and the unknowns are x, y, z. Then rule of cross multiplication gives you x divided by, okay, when you write x, I want you to focus on this part. So it's a small determinant bc, b dash, c dash is equal to y divided by negative of, now I want you to close this part so that you get a, c, a dash, c dash. and finally is equal to Z divided by determinant A, B, A dash, B dash. So remember, this is called rule of cross multiplication. You can use rule of cross multiplication when you have two relations in three unknowns, of course, first degree relations. Okay, now the last and a very important rule. Look at this. Suppose we have two planes P1 equal to 0 and P2 equal to 0. By the way, assume that these planes are not parallel. That means they intersect. And I showed you when two planes intersect, a line will be formed. You have to understand there will be infinite number of planes passing through the same line. You can draw infinite number of planes passing through the same point, same line. And all those planes will be given by P1 plus some lambda plus P2 equal to 0. Okay, we can visualize this very easily. So look at this. Okay, so take a look at this. I took two planes randomly. I just typed some numbers because I know that any relation of degree 1 in x, y and z will give me a plane. So I took two planes. I think you're able to see the equations. X plus 2y plus z equal to 1 and 4x minus 2y plus 10z equal to 5. Now, as I told you before, when two planes intersect, a line will be formed. Now you have to understand, you can draw infinite number of planes through this line. If you want, and it's very interesting. What I'm going to type is the first equation. I think you can read the first equation. X plus 2y plus z, and I'm going to take that constant to the left hand side. Now I'll put plus and I'll type some constant. I'm going to put the constant 3. And now I'm going to take the second equation. That will be 4x minus 2y plus 10z minus 5, and I'll put equal to 0. Did you see that? A new plane popped up. See, look at this. What I did is I took the first equation. Okay, if you want to see that new plane, I'll do one thing. I'll make the first two planes disappear. See? You can do this experiment. I'll repeat once more. So we have two planes P1 equal to 0, P2 equal to 0. They create a line. And what I told you is, you can draw infinite number of planes in such a way that all those planes will contain this line. And all those planes will have equation P1 plus some constant into P2 is equal to 0. So that's it. So I'll be back with another video, and in that video we will start with problems related to straight lines and plane in 3 dimension. But now remember, all the formulae should be in very good condition. Equations of lines, equations of planes, and then we will be able to do the problems or the numericals very easily. So I'll be back with another video very soon. So till then, my friends, bye.